Hello viewers, welcome to Civil Engineering Study and Construction channel. Our today's item for the discussion is foundation of the structure. As this chapter is too long, that's why I will discuss this chapter part by part. Today, this is part 1. And before starting the main point, I will request to you all to please subscribe this channel. Those who have not yet subscribed, and press the bell icon all for all the updates of this channel. So let's start. Foundation. See, every structure has two parts. First one is above ground level and another one is below ground level. The portion above ground level is called superstructure and the portion below ground level is called substructure of that structure or foundation of that structure. See here, say this is a structure. This is a structure. This is ground level. This is ground level. This is the structure. This is ground level on which the foundation is resting. So this part is called superstructure, and this part is called substructure or foundation. This is the substructure, superstructure and foundation of the whole structure. See, foundation of a structure is very much vital. Very much vital. Due to this, for the designer and during construction also, very much care is to be done, very much care is to be taken for this. As the foundation is embedded in the earth, any defect or any failure cannot be detected till it is reflected in the superstructure. If any damages occur in the superstructure, then it can be rectified easily. But if any failure in the foundation, it cannot be detected. So after detection, after watching in the substructure, that repairing is to be made, but it is very much difficult as it is embedded in the earth. Now, see all the loads coming to the superstructure, like dead load, live load, seismic load, wind load, all the loads in the superstructure are transferred to the substructure or foundation, and then foundation transmits the load to the underlying soil uniformly. See, this is the whole structure, this is superstructure, the load P is coming to this superstructure and ultimately it is here in the foundation, and this foundation is distributing load to the underlying soil. This is underlying soil over which the foundation is resting. This foundation transferring and distributing the load, total load, to a wider area of underlying soil, so that intensity of load does not exceed the shape bearing capacity of this soil over which the structure is resting. Now we will discuss about the function of a foundation. What are the foundation's functions? See, the foundation is one of the most critical components in a structure's construction as it serves several essential functions. Which are the functions? Number one, and the main function is load distribution. See here, this is the whole structure, this is superstructure, this is substructure or foundation of the structure. So the load through superstructure is coming to the foundation and then it is being distributed to the underlying soil evenly and on a wider area. This is the function of load distribution. The foundation evenly distributes the weight of the structure over the soil or rock beneath it. This prevents excessive stresses and potential setting or sinking of the building. Second item is stability. Stability of the structure. To stability. It provides a stable base, ensuring the structure can withstand forces like wind, earthquakes, vibrations without tipping or collapsing. This is the function of stability. This is the second function. Third function is prevention of settlement. Prevention of settlement. Prevention of settlement. Foundation minimize uneven or excess settlement, which could lead to structural damages such as cracks or tilting over time. Now, the fourth function of foundation. This is anchoring. Anchoring of the structure. Anchoring. Foundation anchors the structure to the ground, keeping it in place and preventing horizontal movement due to external forces like wind or water flow. Whatever the horizontal forces may be, it prevents from the shifting or horizontal movement or lateral movement. This is the function of anchoring. And the next one is moisture protection. Fifth one is moisture protection. This is the fifth function. Foundations often act as barriers to moisture and water from the ground, preventing dampness and damage to the structure above ground. This is the function of moisture protection. Next function is frost protection. Frost protection. Sixth, frost protection. In colder region, foundations are designed to go below the frost line to avoid damage caused by soil expansion during freezing. And the seventh function is durability and longevity. Durability and longevity. A well-designed foundation ensures the overall lifespan of the structure by preventing structural failure over time. This is the seventh function. So ultimately, total 7 functions are there of the foundation: load distribution, stability, prevention of settlement, anchoring, moisture protection, frost protection, and durability and longevity. Now I will discuss the foundation failure. Why a foundation may be failed? See, type and design of foundation depends on various factors. It depends on size of the structure, intended load on the structure, the quality or type of soil beneath the foundation, environmental issue, like these reasons. Foundation failure can result from various factors leading to instability of the structure and ultimately collapse of the structure. So there are few reasons I am giving here in the reasons for which one foundation or one structure may be failed. Number one reason is soil related defects. One, soil related defects. Under this head, different defects may be seen. So, what may be the defect due to soil? Number one, inadequate bearing capacity. If the soil is loose and the bearing capacity is not too good, then this defect may occur. Next, soil settlement. Soil settlement. Unequal settlement or excessive settlement may lead to the foundation to failure. Number three, soil erosion. If there is soil erosion due to the flow of water under the foundation, then that foundation may be failed. Number four, black cotton soil or expensive soil. Such type of soil may increase in volume when it is wet and shrinkage when it is dry. So due to this differential nature, the movement may occur there of soil and subsequently the structure or foundation, then that foundation may be failed. Reason may be type of foundation. Selection. It means selection of type of foundation was wrong. Another type of foundation was suitable, maybe suitable there. And another point is shallow foundation. Shallow foundation means the earth level where the foundation is now resting is not sufficient bearing capacity. It has not good earth. That's why the foundation cannot bear that soil. Third reason may be poor construction activity. Poor construction activity. Under this head, one point may be use of substandard materials. It means if we do not use the good material like brick, cement, sand, stone chips, etc., then it may lead to the collapse. Another point may be lack of compaction. Lack of compaction below the foundation ground, which may lead to excessive settlement causing collapse of the structure. Number C may be wrong reinforcement. in RCC foundation. When the foundation is RCC, the reinforcement for that should be according to design, considering the load coming on the structure. If there is any fault, the foundation may be collapsed. And not only the quantity of reinforcement, everything like binding, bending, etc. should be proper, otherwise the foundation may be collapsed. Fourth point may be water related problem. Water related problem. Number one, inadequate drainage. Inadequate drainage. Due to excessive water in the foundation trench or foundation pit or around the foundation, it may fail due to the hydrostatic pressure of the water, and it decreases the bearing capacity of soil. Another point may be leakage of underground pipe. If there is any leakage in underground pipe near the foundation, then the bearing capacity is decreases substantially. In that case also, the foundation may be failed. Another point is flooding. If flooding water or flood water there is present around the foundation, automatically the bearing capacity of soil decreases and foundation may be failed. Fifth point is environmental problem. Environmental problem. Under this, one reason may be seismic action. If during design of the foundation seismic force are not allowed, then any seismic action may cause the failure of the foundation. There may be temperature variation. Due to freeze thaw in cold area, expansion of soil may lead to failure of the foundation. Another point may be tree roots. If tree roots reaches under the foundation or around the foundation, then it may cause the crack of the foundation and ultimate failure of the foundation. Point may be human activity. This may due to inadequate maintenance. Inadequate maintenance. Number two may be additional load. Additional load application. Sometimes it is happen that you have made a building of 2-story and suddenly you constructed another story over that double-story building. So additional load obviously lead to the failure of the foundation as well as the. Another point may be excavation nearby for fresh construction. If we excavate the earth for a new construction nearby the old construction, and if we do not follow the rules, then the existing building may be collapsed. Another point may be natural calamity. Natural calamity or disaster. For this, excessive flood, excessive rain, and others different natural activity may lead to the collapse of the building or foundation.
Now see how we can prevent the failure of a foundation. Failure of foundation can easily be prevented if we follow some rules and regulations, for which we need proper design, proper construction practice and maintenance of the structure. So if we summarize these points, number one, proper site investigation. Before taking up the design of the foundation, we need to thorough investigation, geotechnical investigation to understand the soil nature, soil properties, load bearing capacity, groundwater level, etc., and to see whether the earth is expensive soil or not. Before taking up the construction work, we need to check very carefully the compaction and stabilization of the underground soil below foundation. Otherwise, the foundation will settle excessively and there may be failure. Proper foundation design. According to the bearing capacity of soil, the foundation is to be designed as shallow or deep, for which the soil is there on which the foundation is resting. Proper factor of safety is to be considered during design of the foundation. During design, points to be noted for consideration like the local environmental condition like flood, seismic condition, the temperature variation, etc. These points are to be taken into care. And after construction, every part of the structure should be cured properly. For reinforcement work, the placement of reinforcement and binding should be as per drawing and specification, which may affect wrong work of which may affect the stability of the structure. Drainage and moisture control under the foundation and around the foundation is to be kept in knowledge. According to the locality, seismic and dynamic load should be considered during the design of the structure, and overloading to the structure should be avoided all the times. No load is to be placed over designed load. Overall, always the maintenance works are to be carried out very carefully on the structure to make it long life. However, viewers, this much in this video. I will meet you in the next video with more few points like shallow foundation and many more. So if you think that this video is useful to you, please like and share. And if you have any queries, you may please write in comment box. So meet you in next video.